to study about the confirmatory factor analysis and model assessment, that how your model is good in terms of different reliability tests. So first you have to load your model like this, and I hope that I assume rather that you already know how to make a model like this. And if you do not know, go and watch my previous video in which I have discussed about the basics of loading a research model in Amos, SPSS Amos. So when you put your latent variables, like I've got here 5 latent variables: VR, SMA, ONPP, OFF, and PD, right? And all of them have three uh, instruments, and all these three instruments, VR1, VR2, VR3, they are measuring VR. SMA 1 2 3 measuring SMA like this, ONP 1 2 3, all these, okay. And then now you have to connect all of these with these arrows, right? So they all should be connected together for confirmatory factor analysis. So you have to kind of do covariance with all of these. So the second one with all of these, and the third one with all of these, and this one. So I've done this already. I've connected them all, and now I have to run my analysis. So I have to calculate the estimates. And here, this red button, you have to click here to show the loadings here. And these are standardized estimates, and these are unstandardized estimates. You can see that these are the regression weights uh, between these two variables. It shows that how this OFPP and PD are they are strongly correlated. This is 68, and these all are factor loadings, that how do these variables load onto this VR, or how these all explain this VR. You have to go to this tab here, view text, right? So in the view test, here you have to go for the estimates here. So different estimates have been given to you, and before that, if before running this model, you have to go to this analysis properties as well. The maximum likelihood should be ticked on in the output, so all these minimization, stress, standardized estimates, and square multiple correlations, or any other you, if you want, you can just do that as well, like correlation estimates, and direct, indirect, and factor weights, whatever you want, you can just select them, and then you can run these ones. Okay, it does not matter really. Okay, so now you can go to this view text here, and this will give you these are the estimates for all of these, right? So ONPP to 1, OFP, all these are, and then these are standardized regression weights. These are standardized regression weights, and these are covariances, and these are correlations and variances. So these all are the details. So square multiple correlations. So what we need for in factor analysis for model assessment, right? So I will just show you what all we need in a paper. Yeah, so this is a paper which I have recently completed my write up, and it's under review as well. So what we need is we need CR, right, composite reliability, and AVE, MSVE, and all these we need. Okay, and there are two type of tests basically. Okay, the one is you need internal consistency and discriminant validity. So the internal consistency shows that how much these variables v are 1, 2, and 3, they are internally consistent, right? They are reliable and they all are related with this voting realignments vr. So we have got couple of tests which show that the internal consistency of our model, and factor loadings are one of them. So these factor loadings should be greater than zero point 0.7, or even greater than zero point 0.6 is still acceptable. The Cronbach alpha is also there. It should also be greater than zero point 0.7. This also shows that the model is internally consistent, right? So the CR, composite reliability, this also shows the internal consistency. In AVE, so the AVE also shows internal consistency. So these all are the tests which show that these three measurement constructs, they are reliable, and then they are related, they are explaining the variable of voting realignments. Then there is another test which is discriminant validity. So in discriminant validity, we have to see that these two different variables, they should not be representing the same thing, right? So if this is VR, for example, in these two, I was finding quite a lot of challenging, because these are online political participation and these are offline political participation. So the online and offline, these instruments are quite related to with each other. So sometimes it may happen that the measurement of this offline political participation, OFPP, it can happen that this OFPP too explains more online political participation rather than its own offline political participation. So, what should happen ideally is that these items should explain more this offline political participation than the online political participation. Okay, so measure that we need discriminant validity. So discriminant validity means that these variables are explaining their own variable more than anyone else. So for discriminant validity, we have got this Forner-Larker test, right? So I'll explain that how to find these values of discriminant validity and internal consistency. So we have got, there's a long, quite difficult procedure, long calculations to find this test of Forner-Larker test of discriminant validity, but there is a shortcut as well, and there is an Excel sheet, and using that Excel sheet, we can quite easily solve this problem. So what we have to do is we have to put the values of correlation table here and standardized regression weights here. So if we put these values here, so it will automatically give us all the required tests. So what I will do is I will just put this Excel sheet in the description so you can download. So there are different type of auto tests which have been already set in here. The formulas have been put in this Excel sheet. So there are different type of tests like heterogeneity test, outliers, and there's so many. But you have to go to this validity master. So some person has already made this one. to make the work easier. Otherwise it's quite complicated to measure all these tests. So now I will just go through and show you how to do that. So first what we need is that we have to paste correlation table in A2. So this is A2, we have to paste here correlation table. So we'll go to here and over here correlation table. Yeah, these are our correlations, right, which we got from the Amos one. So we have to just select these correlations and control copy, and we have to paste it here, right? So I just paste it here, and standardized regression weights here. So now again I have to go here in my table, standardized regression weights. Yeah, these are standardized regression weights and these are unstandardized ones. So be careful, you have to select the standardized ones. All right, so I copy these from here and then I paste this in the table here, and then you have to be careful of these things. Your latent variable names should not in like f1, f2, f3, like the ones which I've given, vr, onp, ofp, br, these ones, these latent variables, sma and all these, they should not be f1, f2, f3, right? So if that is the case, you should change these names, right? So all these names should not be here, f1, f2, f3 and all that stuff. Otherwise there will be problem in your results. So the second requirement is that these error terms should not end with the numbers. So it's e1, e2, e3, this type of numbers are there, it's good. So like I have here, you see, e1, e2, e3, this is good. If these are just 1 2 3 4 5 numbers, if you give to them, there may be some problems. And then your variable names should not have this ave and cr and msv, because this table needs to calculate these cr in ave, so your latent variables should not have these names, and you should have more than two latent variables. So I have got five here, so you should have at least more than two. I have to click this button, and you see it gives me, wow, you see there's a no validity concerns. So I've got here, you see this, these are my four discriminant validity. All right, so these are, this is the one in which you see the, oh, these are my variables here again. So if I see, and these are CR values here, these are AVE values here, these are MSV values here. So what I need is that these CR values should be greater than zero point 0.7 or greater than 70, and AVE values should be greater than zero point 0.5, and this MSV should be yeah, smaller than AVE. And for this discriminant validity test, right, so you should look for these values in the diagonals. So these values you should always have a look, and these should be greater than the values inside here, should be smaller than the value of a this value in the top or in the diagonals, OFPP, OFPP, right? So the values in the diagonals are the bold ones, they are greater than the values inside, which I have highlighted in the red. So if I look for this 0.677, it should be greater than this 0.467 in all these, right? So how do I write these ones? I can again show you here. So these values, the AVE values and CR values and MSB values, you can just copy them and paste them in your research paper. So I can show you in the example here, you see. So the CR values VR, this is 0.82, AVE is this one, MSV and VIF. So VIF and Cronbach alpha, these two you can calculate with the help of SPSS, right? So the VIF should be smaller than 3. VIF should be smaller than 3. So you can just write the VIF of all of these. And factor loadings should be greater than 0.60 as I discussed. So these all the things, they show you internal consistency and reliability. So yeah, the values for AVE, factor loading, Cronbach alpha, and CR should be above zero point 0.5, zero point 0.6, zero point 0.7, and zero point 0.7 respectively. So this AVE should be greater than zero point 0.5, factor loadings should be greater than zero point 0.6, and this Cronbach alpha and CR should be greater than zero point 0.7. And the values of MSV should be lower than AVE for all the variables. The values of VIF should be smaller than 3. So in your research paper like this, at the end you can write the note here. And for for discriminant validity, we have used this test. And so the for all the constructs, the square root of AVE has been given in both diagonals. So the values in this diagonals, these one is square root of AVE, average variance extracted, and these are the correlations between these two variables. For example, this 0.421, this is correlation between VR and OFPP. So the correlation between these two variables should be smaller than the square root of AVE, which has been calculated here. So as we have seen that these all values were calculated automatically for us by that spreadsheet. But if you otherwise, what it happens is that you have to do it manually one by one, and whenever there is some problem, your all calculations go wrong. So that is a very lengthy process. But I can show you that in one example how to calculate this square root of AVE. So first, if you find the AVE, for example, I can see that this one OFPP. So my OFPP has AVE. It is here. This is AVE, and my OFPP is here. This one, offline political participation, and AV is 0.748, right? 0.748. So what I do is 0.748 square root. So 0.8648. So this is 0.8648 is the square root. So you see 0.865. So I've rounded up to it has automatically rounded up to 5. So 0.865. So this is square root of AVE here, and the square root of AVE of OFPP should be greater than all of these correlations of all variables with OFPP. In the similar way, the square root of AVE of VR, this is VR here on both sides. So this should be greater than these all, and it should be greater than this as well. For example, if you have to see for this one, you should look towards all directions, okay? It's not just like that you look on this column. You have to look here. It should be greater than these values, and it should be greater than these all values, 0.751, right? So it's greater than these values, and it's greater than all these. So vertically and horizontally you have to see that it should be greater than all these. So this is how you have to test for discriminant validity. So this discriminant validity shows that these variables are different from each other. It's not like that the same variable is being measured twice, like online political participation and offline political participation, like this. So these all are different variables. It shows discriminant validity. And the internal consistency in validity uh, is like that how the variables are internally consistent. Within the variable, the constructs are internally consistent. I can show you some more, from the papers. So you see internal consistency. So Cronbach alpha composite reliability, it shows that the internal relationship of the observed items are reliable. Okay, so this paper also explains that explanatory research, the values of composite reliability in all these should be in these values. In convergent validity assessment to measure the level of correlation of multiple indicators of the same construct are in agreement, and for that we need the factor loading CR in AVE. So these all things, right? So these all CR, AVE, and factor loadings, these all indicate the convergent validity, that how the constructs are converging within the variable, and the discriminant validity. So there are different tests. HTMT is one of the tests, but mostly people use this Forner and Larker, as I've explained before. So I think that was all. Thank you very much for watching this video. If you have any questions, you can post in the comments, and I will try to make another video for that. So if you like this video, please hit the like button.